Welcome to our competency-based question series, designed chapter-wise to enhance your conceptual learning and understanding. Question 9. A pole stands in a pool of water such that the sun shines at an angle as shown in the figure. The ratio of the height of the pole above the water, denoted by A1, to the inside the water, denoted by A2, is under root 3 by under root 55. We need to complete the ray diagram first, and we need to show the formation of the shadows of the pole on the water surface and at the bottom of the pool. Also, we need to find the ratio of the length of the shadow of the pool on the water surface to that at the bottom of the pool. And we have to take the value for the refractive index of water as 4 by 3. And we need to prove that this ratio of the shadows is 1 by 4. That's what we need to prove. So let's try to complete the diagram first. So here will be the diagram. See, this is the shadow length above the water surface. So let me call this shadow as OP. And since this ray, it is going inside the water, it will be moving from rarer medium to denser medium. So it will bend towards the normal and it will trace its path like this. So this is the refracted ray, and this complete length, that is denoted by QR, is the shadow length at the bottom of the pool. So let me just give the name to these lengths. OP can be denoted as B1, and if I take this normal all down to the bottom of the pool, this will again be B1, and this I have denoted as B2, and this length will be A2. Now what is given to us? That A1 upon A2, that is height of the pole above the water surface to the height of the pole below the water surface, it is under root 3 divided by under root 55. And what is there to be obtained? We need to find B1 upon B1 plus B2. And for the part 1, the shadow of the pole on the water surface is OP, and shadow at the bottom of pool is QR. And this is, we need to find B1 divided by B1 plus B2. Let me give the name to these as well. So let me mark this point as M and this point as N. So part A is over. Now let's try to find out part B. So for part B, in triangle OPM, tan 60, that is perpendicular upon base, that will be equal to MP upon OP, and that was equal to A1 upon B1. So from here I can write B1 is equal to A1 upon 1060, and B1, it is equal to A1 by root 3. Tan 60 is root 3. So this is equation number 1. Now let's try to find out this B2 as well, because we have already obtained B1. Once I know B2, I can take the ratio B1 divided by B1 plus B2. So for that, we have to apply the Snell's law. So first, applying Snell's law. So I can write sine I upon sine R is equal to 4 by 3. That is the refractive index of water with respect to air. And this is my angle of incidence I, and this is R, that is angle of refraction. So we can conclude that I is equal to 30 degree, because since this angle is given to us as 60, I will be 90 minus 60, that is 30. So I can write sine R is equal to 3 upon 4 times sine of 30. I is 30. So I can take cross multiply and sine r is this. From this I can write sine r is equal to 3 upon 4 multiplied by half, that is equal to 3 by 8. And this is the value of sine r. I have obtained sine r. Let's try to find out cos r as well, because once we know cos r, we can find out the value of tan r, and then we can find out b2. So cos r, it will be under root of 1 minus sine square r. Sine square theta plus cos square theta is equal to 1 using the identity. And I can write under root of 1 minus 9 upon 64. So root of this square of 3 upon 8 is 9 upon 64. So it will be equal to under root of 64 minus 9 divided by 64. That will be equal to 55 upon 64 whole under root. This is the value of cos r. And from this I can write that tan r is equal to sine r upon cos r. That will be equal to 3 upon 8 divided by under root of 55 upon 64. So that is equal to 3 upon 8 multiplied by under root 64 upon under root 55. And finally I can write 3 upon 8 multiplied by 8 upon under root 55. Root of 64 is 8. So that will be equal to 3 upon under root 55. This is the value of tan r. Now in triangle OQN, if I want to write tan r, so tan r is equal to perpendicular upon base, that is QN upon NO, that is B2 upon A2. This implies B2 is equal to 3 upon under root 55 times A2. So from this I can find out A2 is equal to B2 is equal to tan r times A2. So tan r we have already obtained 3 upon under root 55. I have just multiplied it with A2. This is the value of B2. This is equation number 2. So we have obtained two equations. One is the value of B1, and then we have obtained the value of B2. Now let's try to find out B1 plus B2. So B1 plus B2, it can be obtained as the value of B1, it was A1 upon under root 3. So A1 upon under root 3 plus B2, that was 3A2 upon under root 55. So I can write this B2 as 3A2 upon under root 55. I have used this value. Now it was given to us earlier that A1 upon A2, it was under root 3 upon under root 55. So in place of this A2, I can write under root 55 times A1 divided by under root 3. So this will be equal to A1 upon under root 3 plus 3 upon under root 55 multiplied by under root 55 A1 upon under root 3. So I have replaced this A2 from the equation that was given to us earlier in the question. So this will simplify as A1 upon under root 3 plus 3 times A1 upon under root 3. So that is the value of B1 plus B2. I can simplify it as A1 upon under root 3 I can take common, and it will be 1 plus 3 in the brackets. That will be equal to 4 times A1 upon under root 3. So this is the value of B1 plus B2. But we need to find the ratio of B1 upon B1 plus B2. So that is the shadow of the pole on the water surface, that is B1, and shadow of the pole inside the pool, it is B1 plus B2. So that will be equal to A1 upon under root 3, that is the value of B1, divided by 4A1 upon under root 3. So this implies A1 upon under root 3 multiplied by under root 3 upon 4A1. Under root 3 will cancel out, A1 will also cancel out, and we are left with B1 divided by V1 plus V2 is equal to 1 upon 4. And that is what we need to prove. That is the ratio of the shadows on the water surface and at the bottom of the pool has to be 1 by 4. And we have obtained it as 1 by 4. This is the answer for this question.
Keep learning, keep practicing, keep excelling.